Hi friends, let's have a look at problem 2925, maximum score after applying operations on a tree. In this video, we are going to explain a solution based on recursion. So our main purpose is to explain the logic. And besides this, we want to demonstrate how the constraints or assumption of the problem affect us on coding. So with that said, our plan will be the following. First, we are going to digest the problem requirements, and then we look at our idea or logic. And finally, we share the code. So first, let's look at the requirements. So here we have a tree, right, with n nodes and n-1 edges. So the edges are given like ai, bi, right? So we are also given a zero-indexed integer array called values of length n, where value I is the value of the corresponding node I or S node. So we start from score 0, and in one operation we can pick a node I and add the value represented by that value to our score, and then set that node value to be 0. The constraint is that we want to make the tree healthy. The definition for healthiness is the following. A tree is healthy if the sum of values on the path from the root to any leaf node is different than 0. So the requirement is that we want to return the maximum score we can obtain after performing these operations on the tree any number of times. So here we have two examples. So in the first example, the output is 11, right? So in the second example, the output is 14. So we are going to digest this two outputs in our strategy parts. So now let's look at the constraints. So basically this constraint you can go over through, but here I want to mention one, that is n is greater than or equal to 2. In other words, this tree has at least 2 nodes. So this is very important for the coding format we are going to share. We are going to come back to this point later. So with that said, let's look at the strategy. So this problem requires us to get the maximum score. So we can think in a complementary way. So we can find the sum of sum s of minimum retained nodes to keep the tree healthy. Then we just need to return the sum of those values and then minus that s, right? So this is our general idea. So our implementation will be recursion. So here are the sum sort. So for each tree or the corresponding root, then to make it healthy, we have two operations, right? So either we leave the root unpicked, right? Then we can pick all its descendants, right? So this is the one, because the root is already non-zero, so every path has a non-zero sum. So another operation is that we pick the root and make all its subtree healthy, right? So to make its subtrees healthy, we shall leave all the smallest values in the subtree root to leaf path. So we need to compare the two operations and retain the smaller value. Then finally, we need to return the sum of the values minus this smaller value. So this is the general idea. So now let's look at the two examples. So in the first example, so if we retain root 0, its value is 5, right? Then this is the one operation. And also, we can pick the root. And then because this corresponding set is to be 0, right? Then we need to retain node 1 and node 3. Because if we do not retain any of the two, so there's a one corresponding to one path, have 0 sum. Then we can, for the 0, 2, 4, 5 path, we can retain 4 or 5, because both the two have value 1, right? So overall, we can retain nodes 1 and 3, and we pick 1, 5, or 4 to retain. So their sum is 2 plus 2 plus 1, that is 5. For this problem, for this example, it's a coincidence, right? The two operations have the same return value, that is 5. Then we just need to return the sum of the values minus is 5, that is 11, right? Here is a note. So the final return value, in other words, the maximum score, is unique, while the ways to achieve it are not unique. For example, in this here, we can return root 0, or we can pick root 0, right? So the two choices at least. So this is the first example. So now let's look at the second example. In the second example, we can return root 0, and its value is 20, right? So as long as we retain this 0, the tree will be healthy. That's a very simple observation. The second operation is that we can pick the root value. So in other words, we set this value to be 0. And then we can retain those 6, 5, and 1. So for the left, their sum actually is 5 plus 3 plus 10. You can compare these values. That is 18, right? So this 18 is smaller than 20. So this is the value we are going to retain, right? In other words, to keep the tree healthy, we just need to retain 6, 5, 1. Then the sum of these values, this is 58, I guess. And then minus this mean 20 and 18, we're going to get 40. So here, for the left subtree, rooted and true, we retained node 6 and 5, right? Why we retain 6 and 5 in the left subtree, rooted and true? The reason is that the values sum of 6 and 5 is less than the values of at 2, because this 6 and 5, they have a value sum that is 8. Well, value 2 has a value that is 9, right? So we retain this 8. And for the right subtree, rooted at node 1, so we retain node 1 rather than 3 and 4. The reason is that value 1 is 10, right? 10, value 3 and value 4 sum is 11. 10 is less than 11, right? So that's why our choice, right? In total, the first operation, the option is to retain root 0. Its value is 20. And the option 2 is to pick the root value. We'll retain these three nodes. And the retain value is 18, right? This is smaller. So we're going to get 40 for this second example. So the main observation, or one point I want to point out, is that we want to digest that n is greater than or equal to 2. So this tells us what to return for leaf node in our recursion below. So you're going to meet this point when we write the code. So with that said, I hope that you have grasped the main idea. So now let's look at the code. The code actually is very short. So let's use adjacency list representation, right? So we have, let's use a set. So basically, the key will be a node number, let's say 0, 1, something. And the value will be a set. The set contains the neighbors of those nodes. So then we are going to build the graph. So for A, B in edges, right? So tree A and B is in the neighbor of A. So I'm going to do this add, right? Similarly, A is in the neighbor of B. A is in the neighbor of B. So we just do this, right? In other words, bidirectional if we regard it as a graph. So next, I want to write a function to get this return value, to get the minimal return value. So let's see, we call it getMin, right? So in order to avoid repetition of traversal, I'm going to also pass a parent node, right? So the first is that I can call this same function for the neighbors or the children. So for children on node, for children in tree node, in the node neighborhood, if this children does not equal to parent, because parent is also in the neighbor of the node, right? So we need to just use this filter to exclude this case to avoid repetition. And then what we want to do, so if not length the rec, so it means that this node is a leaf node. So for leaf node, so we just need to return the values of this node. So the question is here. So if we have a single node tree, right? So we need to retain that node to make that single node tree to be healthy, right? But here is different. Why didn't we return 0? It's because that the whole tree here, at least we have a leaf. But for leaf node, so we just return that value. So that's the point, right? So this assumption is the reason for we return this value, right? It's due to n is greater than or equal to 2. This is an important point. We hope that you can digest. In other words, for this problem, there's no single leaf node, single node tree. So next, what I want to do is that I want to consider this mean, deduction, or retain. So this will be mean. So either I make all the subtrees healthy. That will be the summation of this list rec. Or I just pick the node value, right? Then what I want to do is to return the mean deduct. So you can introduce this variable, or you can just directly return, right? Return this part. So with that said, we finished this one. So basically, the role of this function is you give us a tree. So we're going to check for these two options, which one have a smaller retain value, and then we get that value. So now what we want to do is the following. So so we just get we sum the values. That's all the values, and then we get the retain value. That is get mean node. So because this, if let's write this node 0. This is the root. Let's define the appearance. Let's say -1. Anyway, any number that is not in 0 up to n-1 will do the job, right? So this is just an imaginary one. So this will give us the maximum score. So before we make any comments, let's first do a test. Yeah, it passes the first test case. Now let's look at the generic case. Yeah, it passes all the generic cases. So here, let me give a quick summary. So in this video, we use the strategy that we think in a complementary way. And also we use the recursion. And one important point we want to demonstrate is that when we write this recursion function or hyperfunction, so for a single node, we return the value of that node. This is due to the assumption that n is greater than or equal to 2 in this problem. The reason is that if we just have a single node tree, so we just need to the maximum score we can get actually 0, right? We should return 0 conceptually. But here, due to the role of this function is to get the smaller retain value among the two options, right? So this is the one option, and this is option 2, right? So with that said, I guess that's about it for this video. Thank you.